How does mechanical energy work? Imagine pushing a swing. As you lift it higher, you store energy in it. When you let go, that energy turns into motion, making the swing go back and forth. That's a simple example of how mechanical energy functions. Mechanical energy is the total energy an object has because of how it moves and where it is. It combines two types of energy: kinetic energy and potential energy. Kinetic energy is the energy of movement. The faster something moves, the more kinetic energy it has. Potential energy is stored energy based on an object's position or condition. For example, a ball sitting at the top of a hill has potential energy because of its height. When an object moves or changes position, its mechanical energy shifts from potential to kinetic or vice versa. But in a perfect system where no energy is lost, the total amount of mechanical energy stays the same. Think of a pendulum swinging. When it reaches the highest point, it has maximum potential energy. As it swings down, that potential energy turns into kinetic energy, and it moves fastest at the lowest point. When it swings back up, kinetic energy becomes potential energy again. The total energy remains constant, just changing form. You can calculate mechanical energy by adding the kinetic and potential energies. The formula for kinetic energy is 1/2 times the mass of the object times its velocity squared. The formula for potential energy is the mass times gravity times height. Gravity on Earth is approximately 9.8 meters per second squared. So, the total mechanical energy is the sum of these two energies. In everyday life, mechanical energy explains many things. When you lift a book onto a shelf, you store potential energy. If you drop it, that energy turns into kinetic energy, and the book speeds up as it falls. When you kick a ball, you give it kinetic energy, which makes it move. A car driving down the street has kinetic energy because of its speed, and a roller coaster at the top of a hill has potential energy ready to turn into motion. Mechanical energy is important because it shows how objects can do work. It helps us understand how machines operate and how natural forces like gravity influence objects. In systems without friction, mechanical energy stays the same, just changing from one form to another. But in real life, some energy is lost as heat or sound because of friction. So, in simple terms, mechanical energy works by combining the energy of motion and the energy stored in position. This allows objects to move, lift, or do work, making it a key idea for understanding how things in our world move and interact.